Welcome to The Explainer. Today, we're cracking open a case file, a big one, the climate case file. The planet's under stress, and our job is to sift through the evidence, follow the clues, and figure out what's really going on. Okay, so every investigation has a central question, right? Here's ours. The Earth's climate is, well, it's showing some pretty serious signs of stress. So what's happening? And maybe more importantly, how can we be so sure? All right, let's start by setting the scene. Think of it like this. Our planet is sending out signals, almost like an SOS. Something is fundamentally different, and we need to figure out how to read these clues. Okay, first things first. Let's get our terms straight. We're not talking about one freak heat wave or a weirdly warm winter. That's weather. Climate change, that's the big picture. It's about long-term deep shifts in the entire system. And yeah, the Earth has its own natural rhythms, its own cycles, but the evidence we're seeing now suggests a new player is dominating the game. So in any good detective story, you gotta line up the suspects. In our climate case, they fall into two main categories. On one hand, you've got your natural causes, things like the sun's cycles or big volcanic eruptions. And on the other hand, well, there's us, human activities. And this is where the plot really thickens. When you look at the forensic data, so to speak, and trace greenhouse gas emissions all the way back to 1850, you find something pretty staggering. Over 75%, three-quarters of those emissions come directly from human activities. Our fingerprints are all over it.
So you might be wondering, how does this actually work? Well, it's all about something called the greenhouse effect. Imagine the Earth has this perfect cozy blanket made of gases. It's totally natural and essential. It traps just enough of the sun's heat to keep us from freezing. The problem is, by pumping out all these extra gases, we're basically throwing another, thicker, heavier blanket on top. And that's trapping way too much heat.
Okay, let's look at the mugshots for our two prime suspects. Suspect number one is the infamous carbon dioxide, CO2. This guy is the most common, making up about 2/3 of the problem. But then you've got suspect number two, methane, CH4. There's less of it in the atmosphere for sure, but don't let that fool you. Methane is a super potent heat trapper. So where's this methane coming from? If we check its ROP sheet, the main accomplices are pretty clear. Over 60% of it comes from just a few places. Agriculture, think rice paddies, leaks from oil and gas operations, and, get this, livestock. Yep, we're talking about cow burps mainly. It sounds funny, but it adds up to a huge amount. Okay, we've got our suspects. Now, let's open up the first evidence file. This one is pretty straightforward, the thermometer. We're looking at the most direct evidence there is, the planet's temperature. Now, here's the kicker. The Earth's climate has always fluctuated, right? Ice ages come and go. But what's been happening since around the 1950s is different. It's on another level. The warming has been speeding up so fast that natural cycles just can't explain it. The scale, the speed, it's completely off the charts. It's unprecedented. And if you want a hard number, here it is. Just in the last decade, the world's average temperature was almost 1 full degree Celsius hotter than it was back before the Industrial Revolution. Now, I know what you're thinking. 1 degree? My kitchen temperature changes more than that. But for the entire planet's average, that is a huge, huge amount of extra energy. Okay, so the thermometer is giving us a clear signal. Let's move to our second evidence file. For this one, we're heading to the coast, because what's happening in our oceans is one of the biggest clues we have. So check this out. For a long time, from the early 70s to 2006, sea levels were rising by about 1.9 millimeters a year, which, was already concerning. But then, look what happens next. From 2006 to 2018, that rate almost doubled to 3.7 millimeters a year. That's not just a trend, that's an acceleration. And in an investigation, a sudden acceleration like that is a giant flashing red light. So why is this happening? Well, the science is pretty clear on the two main causes. First, there's something called thermal expansion. It's basic physics. When you heat up water, it expands. And when you're heating up the entire ocean, that adds up. The second big reason, melting ice. We're talking about massive glaciers and the colossal ice sheets in places like Greenland and Antarctica literally melting and pouring water into the sea. All right, for our last piece of evidence, Let's look up to the skies. All this extra heat and water isn't just sitting there. It's messing with our atmosphere and our weather patterns in some really dramatic ways. You can think of it as a pretty simple chain reaction. Step 1, the planet gets warmer. Step 2, a warmer atmosphere acts like a bigger sponge. It can soak up more moisture. We're talking about 7% more for every single degree of warming. So what happens when that giant super-soaked sponge gets squeezed? You get step 3, more intense, heavier downpour. But here's the thing. It doesn't mean it's just going to rain more everywhere. Not at all. What we're actually seeing is a massive reshuffling of the world's water supply. The evidence shows that some places are getting a lot wetter, while other places, many that are already dry, are getting even drier. It's a classic case of the rich getting richer and the poor getting poorer, but with rain. Okay, we've lined up the suspects. We've examined the evidence. From the thermometer, the oceans, the very sky above us. It's time for the verdict. And the heart of the verdict is this. Greenhouse gases themselves aren't the villain. They're a natural, vital part of what makes Earth livable. But what we've done is crank the dial up to 11. We've pushed the concentration of these gases to levels the planet hasn't experienced in 3 million years. Think about that. We fundamentally knocked a stable system way out of balance. And if you look at the timeline, the story becomes crystal clear. Right around the time the Industrial Revolution kicks into high gear, you see CO2 levels start to tick up. By the mid-1800s, it's not a blip, it's a trend. And today, the two lines on the graph, greenhouse gases and global temperature, are climbing together in almost perfect lockstep. So in the end, it doesn't matter which piece of evidence you look at. Whether it's the rising temperatures, the swelling oceans, or the chaotic skies, they all tell the same story. They all point to the same conclusion. The evidence is overwhelming. The case file is closed. Human activities are the primary force driving the changes we see all around us. And so that leaves us with one final, unavoidable question. The evidence is in. The case is clear. The whodunit part of this story is over. The real question now is, what are we going to do about it?